morning.
Good morning.
I'm going to tell you a little bit about my own work and some other ideas today. And this title, The Body Snatchers, has to do with some disease model that we've been working on here. Okay. So first of all, maybe you've heard of this, but just in case you haven't, that 2013 was the year of the mathematics of planet Earth, and a lot of universities, math institutes all over the world were celebrating. There were a lot of events, and now there was a grant through Rutgers University to do the next year, so Mathematics of Planet Earth Plus, and NIMBioS is involved with that, and it's basically to continue this work. But again, this has a very crucial part of education. So we're interested in the education part of this. And there's going to be a special education workshop related to the mathematics of planet Earth. And that one's going to be at NIMBioS, and it will be in fall of 2015. So and we'll be glad if some of you would be interested in coming, and we'll keep looking for that on our website. So it's going to be not this fall, but a year from now. And there'll be lots of things there, things about fire, forest, water, all kinds of things. So I just want to say that NIMBioS is very active in disease modeling. This is just one area that we're active in, and that's what I was just going to briefly discuss today. And I've been involved with quite a few of these, and especially I've been involved with modeling cats in Knox County, and own cats and feral cats. I've been involved in malaria and feral swine. I'll talk more about that. But one thing, and Ione's disease, the group that was just here the last few days was involved with Ione's disease. And first of all, I'm mostly going to talk about Toxoplasma gondii today. So I guess we had a workshop and then followed by a working group on Toxoplasma gondii. So before we start, do people know what that disease is? Is anybody familiar with that disease? Huh? Yes? 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 What do you want to tell us about it?
Is it causes toxoplasmosis?
Yes?
You can get that from cat litter or whatever.
Yes, right, exactly. So
Yeah.
yes, exactly. Yes, exactly. Right. That's exactly. And so we're going to talk about how this can be thought of as a type of body snatcher. Okay. Yes, exactly. And so they call this the world's most successful parasite because it's in so many different types of animal populations. And so here's just a simple graphic talking about these animals. In particular, this one is concentrating on certain types of primates and that actually have Toxoplasma gondii. And many of these particular mammals, it may be asymptomatic, the infections, but a lot of times there's other animals it has a big effect on, like sheep and goats, and in particular pigs, and also it can be involved in birds and other types of animals. And so just to be briefly talk to you about it here, cats are the definitive host. And so when you think about Toxoplasma gondii, it's a type of parasite protozoa, and it can sexually and asexually reproduce in the cat. But what happens, of course, that the parasite comes out in the fecal matter, and it could be deposited into the environment, and then other animals can get involved. In particular, this picture doesn't have pictures of mice. Oh, yeah, there's a little mice over there. And so there's a cycle frequently between cats and mice. And then, of course, what can happen, it can get involved in some other types of animals, in particular some farm animals. It could come to humans through meats, raw meats or undercooked meats, or it might be like involved in the vegetables, meaning the oocyst, where the protozoan is in the environment. You could get that from digging in your garden, and if you didn't clean your hands well, things like that. And so this really does not bother a female, for example, if she already had the disease or she had it before she was pregnant. The only problem with it is if you get this disease while you are pregnant. It could cause some damage to the fetus or cause an abortion. And so some of these I already said, but that cats are the definitive host, rodents are intermediate hosts. So it can reproduce asexually in mice, but to keep the host cycle going the best, it needs definitive host. So there's different ways of transmitting this disease. And so what I want to talk about is why do we call this body snatchers? And what we really want to talk about that, for example, this protozoan, this parasite, manipulates manipulates mice. So what I mean by that is that normally mice are trying to avoid the cats. And so now sometimes when they have this disease, and this has been documented scientifically, that now the mice can be attracted to the cats. And so that's what we call manipulation. So in order to keep the disease going, the parasite somehow manipulates the host, and now they're not so much afraid of the cats. And so this is my picture about the behavior change. So that has a friendly mice and cats. Okay, but the idea that they're drawn to the mice could be drawn to the cats. Well, also there's been some serious work trying to document that actually if you have toxoplasma gondii, that actually it may make you crazy. Your cat, you might think your cat's making you crazy, but actually it's probably the parasite that you got from the cat. And so there's a lot of work on this, and I don't think it's totally documented, but they just think that people have perhaps do risky behavior and some type of schizophrenia, and so basically there's strange behavior because of this, and so it's getting, Yes, maybe so. But it might just be regular people that are a little crazy. Yes, right. So, not right. So it's a very it's very widely spread across the world, and you see that depends on, in some cases it has unusual damage. It can even sometimes parasites could get in your eyes. That sometimes causes damage to people's eyes. Also, sometimes if you're a person that's immunocompromised, it can get involved in more complicated ways, and you can talk about that it would cause a type of encephalitis. And so this just gives you an idea of the seroprevalence in women in childbearing age. So this would just give you an idea of, once again, they frequently concentrate on the effect on women because of the problem with pregnancies. But you see that some countries it's very, very large, and so it's larger in some places, like, for example, France. It's much larger there. People worry about that in places in South America and places like that. And actually, this is a list of disease burden, and these are disease burden caused by foodborne pathogens. And this is a list, and you see Salmonella is pretty close to the top, but you see also that, and this is actually based on the United States. And you see Toxoplasma is right there, and so number 2. And it also, you can see some of the things that, look at the illnesses and just take a look at it. And so actually, we do study when we're working on this sort of what's happening in terms of the parasite when it can get into like a cyst and be so it transforms between 2 types of stages, tachyzoids and brachiozoids. And so it can be sort of get into a cyst and stay sort of latent. And so what we've done is we've tried to build models, and the models we first started with was really with cats, mice, and the environment, and also include this behavior manipulation. So that's one type of thing we did. And then we try to, you can do like a simple case, just do the cats in the environment. You can do just think about how it could move around in mice, or the point is you could put them all together. And then we are building a bigger model that has actually farm animals and humans. And this is just some ideas of things that we were studying and basically looking at the transmission dynamics and also different types of what happens with manipulation. So the question is, there's vertical transmission of this disease in mice, but not in cats. And so that means that the mother cat does not transmit the disease directly to their newborn, but it does happen in mice. And so the question is, how does this manipulation go together with vertical transmission? So they try to, so manipulation of the mice go with the vertical transmission component, so they study those. Also, which is more important to the pathogen, to do the manipulation or to do the vertical transmission? And maybe how dense a population, whether you're talking about mice in a city or mice in a farm. And so people are studying that kind of thing. And so we have a complicated model with all these rates. These are little all these are rates, like how they move, from back and forth to various compartments. And we have lots of coefficients involved, talking about like a coefficient that keeps up with the manipulation, vertical transmission, how virulent, meaning how it can actually cause mortality. So we try to put all those in there. And these are models of, most of the models we've built are actually differential equations which represent rates of change. We've also built models that have stochastic components in them. And maybe that's a messy thing we don't want to talk about too bad, but this, if you're used to differential equations, it's got 6 differential equations. These are the cats susceptible, infected, recovered. This is the environment, and these are the mice. Okay. And so we start to study this, and you see that we can get some conclusions from the models, and it depends again, playing off these two effects, manipulation and vertical transmission. And sometimes it could be that vertical transmission, it could be more efficient. And again, the density of the host, so basically whether you're talking urban or rural, so that makes a difference. And we're also looking to the long term, thinking about sustainability and how this disease affects public health issues, and what should we study about that. And in fact, if you look across the world, there's lots of different features of this disease in different parts of the world, and we're trying to study that type of thing. And the climate, so the parasite will get into an oocyst and survive in the environment, and it depends really on the climate. And people also try to study the impact of how you handle your meat and how you cook it. And also they're thinking about a lot of these to vaccinate cats, kill the mice, different things. But we have various objectives. One is, again, to look at them and look at this disease in different parts of the world, and also try to study control measures. I also want to mention this disease. This is a separate disease. This is not a body snatcher, but it's again, a disease that you maybe have not heard about. This was the group that was here earlier this week, and they were here yesterday morning. And this is a disease called Johne's disease in dairy cattle. And it has a lot of, a large percentage of farms in the United States have Johne's disease on their farm. And the main thing that happens for Johne's disease is that it will actually cause chronic diarrhea, weight loss, and decreased milk production. But it's a very slow developing disease. It might take like to get to like the worst case, it might like take 3 years. But some people believe that this disease may be connected to Crohn's disease. And so like if you are in Canada, you can buy milk that's Johne's disease free. But in the United States, they believe that pasteurization, cleans out all the Johne's disease. And so this particular pathogen, which is a type of bacteria, and so you don't hear that much about it in the United States. At least in the news, you don't hear too much about it. But it's predicted to be in 68% of the U.S. dairy farms. And to the dairy, when you're thinking about a dairy farm usually wants to keep relatively a constant population. And so if they have to kill cows or sell them off because they have this disease and their milk production is going down, then they have to buy more cows, and they will hopefully buying cows that do not have the disease. And so it's pretty complicated. Also, I just want to talk to you, if anybody's interested in this topic, it's a topic that I'm working on, and I don't know if many of you have actually, has anybody ever seen a hog in the park? One person. Oh, this is a good time. One or two. So you know that people see bears for some reason in the park, but they don't see hogs. But they don't have a good estimate of the number of hogs in the park. And maybe you know that they cause a lot of damage. They're an invasive species. And so we're trying to not just model the hogs, but figure out also about the spread of disease. They're spreading a disease called pseudorabies. And but we have a database with 10,000 entries of all the hogs that have been harvested in the last 20 years, and we're using that database to help shape the model. So maybe you know that every year they harvest about 400 hogs in the park, and they just leave them there for the other animals to consume, or the environment. So it's a bigger problem than you might think. So I just want to point out, for example, this is very complicated what I was doing before, but I sometimes, like when I'm at Bearden High School, I talk to the high school students about very simple disease models. And this is one that I've talked about before, where you have just a very simple model about a cold passing around in a dormitory, and you just assume it's a closed population, and you just have susceptibles and infecteds, and it's closed, meaning that no students are leaving, no one is dying or anything, something. And then you use these simple rates. Each day, 40% become infected, and then 20% that were infected recover. And I usually, draw such a diagram. So you see that I put the 40% up here on the top arrow, and I put the 20% on this arrow. And so you might say, if you try to think this through, I started to make some equations, and these are what you call discrete models. They're very easy. The students at Bearden High School could program this on their calculator or something, or they could just do it over, to calculate what happens over several steps. And so you see that the 0.4 and the 0.2 are in here, but you might say, how'd you get these other two numbers? And the idea is, since it's a closed population, you know that if 40% left the susceptibles, then 60% have to stay. So you can see this is stay. This is the susceptibles at one time step, and this says that 60% of them stay to the next time step. And so this counts for all the population, 60% staying and 40% leaving. And then the same thing happened over here with the infecteds. And you can actually look at this and figure out what's going to happen in the long term, what's the overall percentage of susceptibles and infecteds. And
they will be doing that quite shortly.
Okay, good. And so you can actually sort of take one of these equations and look at the long-term distribution of them. And so basically you say that as time goes on, it's going to level out. And so you can write the equations without the time and just basically solve for the relationships. So, and I've done that at the high school, and it's been pretty good. So actually I thought today, for a moment, I would pass around these graphs and give you a chance to talk to somebody about interpreting graphs. And I'm very interested in general about species population models. And so if you pass that around, you see that if you could just look at that with by yourself or with a partner, and those are graphs from some data in Yellowstone Park, and the dates on there, and there's 4 populations, and this is a paper that it's actually the data is coming from.